Hello madlang people, I am Sreka Mr. Arubilla. I will be tackling about electric potential and potential energy due to point changes. So what do we mean by electric potential? Think of electric potential as a measure of how much electric push or electric pull a point in space because of a charged object. It is like imagining an invisible field around a charged particle that affects other charged particles nearby. If you place a positive charge in this field, it will feel a push. And if it's a negative charge, it will feel a pull. The electric potential is a way to describe this interaction. So ano nga bang pagkakaiba ng potential, energy, and electric potential? So electric potential is defined as the amount of work, energy needed per unit of electric charge to move the charge from a reference point to a specific point in an electric field. So, ito yung formula niya. To find the electric potential at a point located at a distance r from the charge, let's begin with the general expression for potential difference. So for this formula of electric potential, V is the electric points, as you can see in the PowerPoint, and E is the electric field vector. Finally, ds is the differential displacement vector along the path. This expression seems to represent the potential difference between points A and B. The electric difference is calculated by integrating the electric field E with respect to the displacement ds along the path from the point. So these are the other formulas. Then the quantity of E times ds is equal to here, as you can see. All we have to do now is substitute it to the previous formula. So as you can see in the right side of my PowerPoint, substitute na yung previous formula. So to further more simplified it, because it is stating that the Q is conservative, we can say that V equals to K, which is the a column, uh, and the numerator of it is Q over R. We obtain that the electric potential resulting from two or more point charges by applying the superposition principle, that is the total electric potential at some point P due to the individual charges. And for a group of point charges, we can write it the total electric potential at P as here, itong nasa dulo na. V equals K and QI over RI. Ayan sa electric potential na formula. For the next slide, I have here the example of electric potential. Okay, so let me read the first question. So what is the electric potential given 0.58 meters away from an 18 microcoulomb charge? Okay. So, dito naman, as you can see, itong may bilog na to, if the letters are involved, which is the V, R, and Q, it means ang formula na gagamitin ay electric potential, which is the volts, unit of volts. So, dito naman, ang hinahanap ay ang volts. So, we have to use scientific calculator, okay? So, paano natin makuha yon? So, let's start with this formula. So, V equals K. Ang K natin ay 8.988 times 10 raised to 9. Yan yung constant na K or column. While the Q, as you can see in the PowerPoint, 18 times 10 raised to negative 6 column. Yan yung Q. And over R is 0.58 meters. So, pag pinag-times natin yan lahat over R, we will have the volts of 278 and 7.93 volts. Ayan yung makukuha natin na answer. Okay? So, dumako naman tayo sa potential energy. So, in my opinion, the potential energy between them is a measure of the work you'd have to do, either bring them closer together or move them apart against the electric forces acting on them. So the formula for potential energy due to point charges involves the charges on how big they are and the distance between them and a constant that describes how strong the electric force is. To make it short, electric potential is like electric push or pull at a point, and potential energy is the work you'd have to do to move charges against or with this push or pull. So, according to Google, potential energy is energy that is stored in an object due to its position or condition. It is not a force, but it can be converted into kinetic energy, which is energy of motion when the object is released. So I also have the example for this electric potential energy. So I don't have Jamboard and di ko rin alam kung paano gamitin, I mean. So I have to improvise. Okay? So let me read the second question of electric potential energy. So it said here that to calculate the amount of electric potential energy possessed by 2.5 times 10 raised to negative 10 coulomb at a point where the electric potential is 4.70 volts. So again, kapag ang hinahanap natin ang U, ang unit nun is joules, which is the electric potential energy. So, ito yung gagamitin nating formula. Okay? V equals U over Q. So, as you can see here na may bilog. Itong mga bilog na letters na to, na involved, ayun din yung gagamitin natin na formula. That's why I have written that here. Okay? So, the given of Q is 2.52 times 10 raised to negative 10 coulomb, and the V or the volts is 4.70 volts. Okay. So as you can see here, ginamitan ko din siya ng cross multiplication because it is needed and pasok siya sa electric potential energy formula. So as you can see here, 4.70 or the volts multiplied by 2.52 times 10 raised to negative 10, which is the Q. Then we will have 1.18 times 10 raised to negative 9 equals the joules. So the answer here is 1.18 times 10 raised to negative 9 joules. Dahil nga electric potential energy ang ginamit natin dito na formula, so the units will be joules. And now for the formulas of electric potential energy, here, galing ito sa books. As you can see, nilagay ko na ito before, so ulitin lang yan. Okay? Now, let's talk about the potential energy in a system of two charges. If V2 is the electric potential at a spot P due to a charge Q2, imagine bringing another charge, Q1 from really far away to P without speeding it up. The work done by an external agent, Q, Qi, Q1, V2, adds energy to the system. This energy shows up as potential energy U when the two charges are a certain distance apart. And yung R12. In, and in simple terms, the potential energy of the system is given by this expression. So U equals K or the column. The numerator is Q1 and Q2, just the vectors over R12. Okay. It says here that if the system consists of more than two charged particles, we can obtain the total potential energy of the system by calculating U for every pair of charges and summing the terms algebraically. The total electric potential energy of a system of point charges is equal to the work required to bring the charges one at a time from an infinite separation their final position. So I hope you understand my part, and that will be all. Thank you.